You believe walking simply transforms your body, but the most dramatic change actually begins inside your silent brain. This organ consumes enormous energy, yet responds instantly to even the simplest motion you make. Here is the twist nobody expects. The first place awakened by walking is not your muscles. Your hippocampus, guardian of memory and spatial navigation, senses movement before your heart even reacts. Each stride sends mechanical ripples upward, announcing that your body has begun exploring the world again. Blood flow increases toward this ancient structure, carrying oxygen like a cool tide washing inland. This surge is not accidental. It is your brain preparing for another round of internal remodeling. You once learned the adult brain stops growing, but modern neuroscience quietly overturned that outdated belief. Harvard researchers demonstrate that neurogenesis continues far into adulthood whenever movement becomes consistent and rhythmic. Walking introduces an unexpected biological advantage few people ever consciously notice happening inside them daily. As your calf muscles contract rhythmically, they release molecular messengers that travel straight towards your brain. Among them is BDNF, the brain-derived neurotrophic factor, often called miracle grow for neurons. BDNF encourages newborn brain cells to survive, mature, and form stable synaptic networks faster. As levels rise, memory circuits strengthen, learning improves, and cognitive aging begins slowing quietly down. This is where the paradox emerges. Walking elevates BDNF without generating harmful oxidative stress anywhere. High-intensity workouts can overload tissues with free radicals, disrupting delicate neuronal environments significantly over time. Walking, in contrast, stimulates circulation gently, avoiding metabolic storms that overwhelm aging nerve cells. This creates the ideal internal climate for neurogenesis to thrive naturally throughout your entire lifetime. The long-term evidence becomes even clearer when researchers measure structural brain changes over time. A University of Pittsburgh study followed adults walking 40 minutes 3 times weekly for 1 year. Their hippocampus grew by 2%, effectively reversing age-related shrinkage that weakens memory. Sedentary adults, meanwhile, lost nearly 1.4%, a measurable decline in neural integrity. This may sound small, but inside the brain it represents thousands of preserved neuronal connections. Each walk becomes a quiet investment in mental resilience, not just physical well-being. Now the real question forms. If walking can regrow part of your brain, what else changes? What happens when this rising blood flow reaches your arteries, heart, and vascular chemistry? The next transformation unfolds below the neck, and it is far more profound than expected. When increased blood flow leaves your brain, it rushes toward the system holding your survival. Your cardiovascular network, stretching thousands of miles, responds instantly to every subtle change in movement. Here is the surprising truth. Walking does not just strengthen your heart, it reshapes blood chemistry. With each step, blood pushes against your vessel walls, creating gentle friction called shear stress. This friction is not harmful. It is a biological signal your endothelium has been waiting for. Endothelial cells respond by releasing nitric oxide, the body's most powerful natural vasodilator known. Nitric oxide relaxes vessel walls, widens arteries, and allows blood to glide with remarkable ease. This effect happens within minutes, lowering blood pressure without medication or aggressive physical effort required. It is the vascular equivalent of opening a congested highway after years of silent traffic. But the twist runs deeper. Nitric oxide also prevents clot formation and reduces inflammatory signals significantly.
Researchers from the American Heart Association found walking rivals running in reducing heart failure risk. The key is energy expenditure, not intensity, making walking safer for aging joints and arteries. As your vessels widen, another transformation begins inside the microscopic branches of your vascular tree. Your body starts forming new capillaries, a process called angiogenesis, triggered quietly by repeated walking sessions. These new vessels reduce pressure on your heart by improving oxygen delivery to working muscles. Think of it as constructing emergency side roads that prevent traffic jams during metabolic rush hours. This is why consistent walkers often experience improved endurance without ever training like dedicated athletes. Walking also stabilizes cortisol levels, avoiding the hormonal spikes caused by high-intensity exercise routines. By keeping cortisol lower, your vessels avoid chronic inflammatory stress that accelerates arterial stiffening over time. But perhaps the most overlooked change occurs inside your mitochondria, the power plants of cells. Walking places you in Zone 2 cardio, the range that optimizes mitochondrial efficiency most profoundly. Zone 2 boosts fat oxidation, reduces lactate accumulation, and enhances cardiac metabolic flexibility significantly over weeks. It is gentle enough to sustain for long periods, yet powerful enough to remodel your physiology. This is the paradox. Slow movement upgrades energy systems faster than many fast movements ever could. Every step becomes a whisper to your cells, telling them to work cleaner and longer. Yet beneath this growing efficiency lies a deeper biochemical puzzle involving glucose and insulin balance. If your vessels improve this dramatically, what do your muscles actually do with that sugar? To answer that, we must explore a mechanism powerful enough to rival diabetes medication itself. While your blood vessels widen and oxygen flows freely, another silent battle unfolds inside your muscles. This battle determines whether sugar becomes fuel or slowly turns into metabolic damage over time. Here is the uncomfortable truth. Most people do not lack glucose, they lack the ability to use it. Insulin, the hormone meant to escort glucose into cells, becomes less effective when resistance develops. When this happens, glucose lingers in the bloodstream, quietly raising inflammation and accelerating cellular aging processes. But walking introduces a loophole in this broken system, a biological backdoor your muscles still trust. Each step triggers rhythmic contractions that activate a transporter called GLUT4 without needing insulin involvement. GLUT4 migrates to the muscle cell surface and pulls glucose inside like a silent rescue team. This pathway bypasses insulin entirely, offering a second chance for those with impaired metabolic function. Researchers describe this as non-insulin-mediated glucose uptake, a life-saving adaptation during consistent daily walking. A study in diabetes care showed 15-minute post-meal walks controlled glucose better than longer sessions. This finding surprises many, yet it highlights how timing manipulates metabolism as powerfully as duration. Walking right after eating prevents glucose spikes, reducing oxidative stress that damages vessels and nerves. But the twist grows deeper still. Your muscles become metabolic sponges once GLUT4 activates repeatedly. They draw in glucose for hours, stabilizing your blood sugar long after the walk ends. This is why people who walk daily often report fewer cravings and steadier afternoon energy levels. Inside each muscle fiber, mitochondria respond to this steady glucose flow by increasing their overall efficiency. They burn sugar cleaner, produce fewer free radicals, and reduce metabolic waste circulating throughout your body. This dual-fuel flexibility, called metabolic switching, becomes easier the more consistently you walk daily.
It is the hidden reason walking reverses insulin resistance faster than many people ever expect. Yet a deeper paradox remains. Sitting still for just 60 minutes turns this entire system off. When you sit too long, a gene called lipoprotein lipase becomes suppressed almost completely without warning. This decreases fat breakdown by nearly 90%, weakening your metabolic engine significantly over time. Standing and walking for even 2 minutes reactivates this gene and restarts lipid processing immediately again. Your metabolism is not slow by nature. It is slow because modern life keeps it immobilized constantly. But when you walk, you realign your biology with its ancient design for constant movement. And once glucose is controlled, something even more remarkable begins within your immune system entirely. A system without a pump suddenly depends entirely on your steps to stay alive, functional. Once glucose stability returns, your body shifts attention toward a system operating quietly in the background. This system carries immune soldiers, removes cellular waste, and regulates inflammation without any internal pump existing. Here is the twist. Your lymphatic network depends entirely on movement to stay alive and functional. Unlike blood, lymph cannot rely on a heartbeat. It waits patiently for your steps to begin. Every stride triggers mechanical pressure that pushes lymph upward through narrow vessels and deep channels. Your calf muscles act like organic pistons, squeezing fluid upward with each controlled muscular contraction. This is why physiologists call the soleus muscle the body's second heart during daily movement. Its rhythmic compression prevents lymph stagnation, a key driver of swelling, fatigue, and chronic inflammation. Without walking, lymph moves sluggishly, allowing toxins to linger and immune responses to weaken gradually. Walking transforms this passive network into a dynamic cleansing system operating quietly beneath your skin. It transports pathogens toward lymph nodes, where immune cells perform microscopic inspection and active defense. Inside these nodes, B cells and T cells neutralize threats with remarkable precision and impressive speed. This cellular choreography intensifies when lymph flows faster, creating a more vigilant and active immune patrol. A study in the British Journal of Sports Medicine demonstrated this effect clearly and quite convincingly. People who walked 5 days weekly experienced 43% fewer days of respiratory illness overall. The benefit did not come from medication, supplements, or restrictive diets, but simple mechanical motion. Movement awakens immune circuits that cannot fully activate during prolonged sitting or extended physical stagnation. As lymph circulation improves, inflammation markers gradually decrease throughout your muscular and connective tissue systems. This is why many walkers report lighter legs, reduced swelling, and more comfortable joint mobility daily. Walking also improves venous return, reducing pressure that contributes to fluid buildup in your extremities. But the deeper shift occurs at the level of interstitial spaces between your body's trillions of cells. These microscopic gaps store metabolic waste, damaged proteins, and inflammatory byproducts accumulated from your daily life. Lymphatic flow is the only mechanism capable of clearing these residues efficiently and continuously throughout life. Walking, therefore, becomes the foundational mechanical requirement for cellular cleanup across your entire physiology system. It is not optional wellness, it is a hidden survival mechanism written deeply into human evolution. Your immune resilience depends on this motion far more than most people realize consciously every day. But even as your immune system strengthens, another transformation is quietly unfolding beneath your skin's surface.
Walking begins influencing not just fluid balance or metabolic waste, but the biology of aging itself. Your chromosomes respond to repetition, rhythm, and movement in ways few people expect until proven. Telomeres, the protective caps of your DNA, adjust their behavior according to your daily step count. As your immune system strengthens, the most surprising transformation begins deeper than any organ or vessel. It unfolds inside the nucleus of your cells, where genetic code interprets every step taken. Here is the unexpected truth. Walking can genuinely influence how your chromosomes age over the years. At the end of each chromosome lie telomeres, protective caps preventing genetic material from slowly unraveling. Every cell division shortens these caps slightly, bringing each cell closer to senescence and eventual decline. This shortening is one of the most reliable indicators of biological aging ever discovered by scientists. But walking introduces a twist that challenges the inevitability of this gradual genetic erosion process. Regular movement activates enzymes called telomerase, which help maintain and repair telomere length over time. This shift does not reverse aging completely, but it slows the biological clock quite meaningfully. A groundbreaking study from the University of Leicester demonstrated this effect at a massive population scale. Researchers analyzed over 400,000 adults and found brisk walkers had significantly longer telomeres overall. The difference equated to roughly 16 years younger biological age compared to consistently slower walkers. This was not a minor statistical variation, it was a measurable signature of genuinely healthier aging. Walking acts like a biological message, telling your cells the environment is stable and supportive.
In evolutionary terms, a body in motion signals resilience, prompting cells to invest in longevity. Meanwhile, reduced inflammation from improved lymphatic flow further protects telomere structure from oxidative stress damage. This combination creates a cellular environment where aging slows rather than accelerates uncontrollably over decades. Yet another layer of the paradox emerges when comparing walking with intense, exhausting physical training programs. Overtraining elevates cortisol and free radicals, harming DNA and accelerating telomere shortening quite significantly overall. Walking, however, stays within the sweet spot, providing stimulus without overwhelming your cellular defenses entirely. It is gentle enough to protect genetic material, yet powerful enough to trigger molecular repair processes. As activity rises, damaged DNA segments receive more consistent maintenance and ongoing structural stabilization throughout time. This contributes to better mitochondrial function, improved cellular energy, and far greater metabolic flexibility overall. These genetic benefits accumulate quietly, noticeable only across months and years of consistent daily movement. Your biological age begins diverging from your chronological age, favoring a much slower internal decline. But the story does not end with chromosomes or cellular repair alone. More remains unexplained. Because once telomerase has done its work, your physiology starts asking one important final question. How much walking is enough to sustain these changes without slipping into diminishing returns eventually? And that answer, surprisingly, has nothing to do with the famous 10,000-step rule. By now, your brain, heart, metabolism, immunity, and DNA have responded to every step taken. But the final question remains: how much walking is enough to reliably activate these transformations consistently? Most people cling to one number, 10,000 steps, believing it carries scientific authority and precision. Here's the twist. That number did not come from research, but from a marketing campaign.
A Japanese pedometer named Man-po-K translated to 10,000 steps meter, and the myth was born. The real science, however, paints a far more nuanced and liberating picture for your daily routine. A study published in JAMA Internal Medicine examined long-term mortality risk and daily step counts carefully. Researchers found health benefits plateaued around 7,000 to 8,000 steps, not the mythical 10,000. Beyond that threshold, improvements in longevity increased only slightly with diminishing marginal returns overall. This means walking does not demand excess, it demands consistency timed to your body's rhythm. To activate metabolic flexibility, aim for a cadence of at least 100 steps per minute. This pace places your body in the ideal cardiovascular zone without overwhelming hormonal balance unnecessarily. Walking slower still benefits the lymphatic system, but brisk walking maximizes mitochondrial and endothelial gains. Your timing matters even more than your total distance or total steps counted daily. A 10 to 15-minute walk after meals significantly reduces glucose spikes and insulin load. This effect occurs because GLUT4 transporters activate independently of insulin during gentle post-meal walking. This single habit can outperform longer morning walks in stabilizing blood sugar across 24 hours. Terrain also influences adaptation, with inclines engaging posterior chain muscles and improving knee stability progressively. Walking backward, supported by evidence from strength rehabilitation programs, strengthens knee tendons safely and quite effectively. But the deeper truth is simpler. Walking should mold itself around your life, not the reverse. Your biology prefers rhythm, repetition, and moderate strain delivered patiently rather than extreme bursts of effort. You do not need marathons, speed, or punishment. You need patterns your ancient physiology already recognizes. Humans evolved as persistent movers, relying on steady motion rather than intense, sporadic bursts of activity. When you walk daily, you honor that blueprint and restore a rhythm modern life has stolen. Your genes, mitochondria, neurons, and immune cells all respond as if remembering something deeply familiar. They recognize walking not as exercise, but as the native state your human body was designed. This is why every step carries influence beyond calories, shaping systems that cannot speak yet respond.
So yes, walking is not optional wellness, it is a biological necessity hiding in plain sight. It is the movement that resets your brain, calms your chemistry, and extends your healthy lifespan.